So here's a parametric equation question. It's quite nice. I always like these type of questions. We're first of all asked for the point A and point B. Coordinates of point A is to find a point B to show that. For some reason they've given one to show that, but really we're going to use the same method for them. We're going to equate y equals to naught. T cubed minus 9t equals naught, which gives us t plus 3, t minus 3 equals naught. And then so that gives us t equals naught, t equals minus 3, and t equals 3. Now it shouldn't surprise us that we've got 3 solutions here, because we've got 3 points so we can actually see where they cross. Now the t equals to naught one, don't need to write this down, but we can see that put naught in there and we get y equals naught. So t equals naught corresponds to that one. They're not asking for that because it's kind of obvious. But then if we put t equals to minus 3 in, if we put when t equals to minus 3, x equals to minus 3 squared plus 2 times minus 3. So that gives us 9 minus 6, that's 3. So it tells us that point A is at 3, naught. And the other point will be our point B, where they're asking us to show that it's 15. So that's 3 squared plus 2 times 3. And that is 15. So that tells us that point B is 15 naught as required. There we go, so that's that one. Let's make a bit of space here so I can get on with it. I'm going to need it. Okay, part B is to find the equation of the tangent at B. So basically the equation of this line here. Now we've already got the point at B here that we just found. So we just need to work out the gradient, and to do that, it's kind of related to the chain rule. We can just differentiate dy by dt and dx by dt, and it would be the quotient of those two. So that's 3 to t squared minus 9 over 2t plus 2 . Okay, so that's our general expression, but we want that for the point at B, and we know that t equals 3 at the point B. So when t equals 3, we've got dy by dx is equal to 3 times 3 squared minus 9 over 2 times 3 plus 2. And on the top there I can see I've got a 27 minus 9, which is 18. And I've got a 2 times 3 over 6, which is 8, plus 2, which is 8, which is 9 over 4. This looks promising because I can see what I'm trying to find. It has a gradient of 9 over 4. Looking ahead, it's always worth taking a peek to think if your answer is reasonable, and it is. Better to iron out mistakes as we go rather than just find 4 lines down that we made a mistake. So that's looking right, especially. So now we can just use y minus y1 equals mx minus x1. So y minus y1 is equal to mx minus x1. So we've got y minus naught, in fact, because we've got a coordinate of 15 naught here. Y minus naught is equal to 9 over 4 x minus 15. I think that's pretty much does it, doesn't it? We've got 4y equals 9x minus 15. So that gives us what, certainly gives us what we've been asked to show. 9x minus 4y minus 135 equals 0 as required. Okay, so that's just to find the equation of this tangent here. Right, now the next bit's quite nice and interesting actually. If you look at if we put in and sub in our values for x and y, our things from the parameter in x and y, we'll get a cubic. Might not look promising, but what the solution to that cubic will correspond to the points at t where, this relationship holds and are on this curve. In other words, those points. And because of two of them, and one of them we already know, it should not be that difficult to factorise. So it may not look promising as we go along, but if we use the fact that we already know that we have a couple of roots here, it's a repeated root because it touches, it shouldn't be too bad. So here we go. Let's sub in. We've got 9 bracket t squared plus 2t minus 4 bracket t cubed minus 9t minus 135 equals 0. So multiply that out, we get 9t squared plus 18t minus 4t cubed plus 36t minus 135 equals 0. Okay, let's tidy that up. It's always best to have the term in t cubed positive. So let's just change the sign of everything. Just take care as we do this, so because we're combining things as well. We've got 4t cubed, and then there's no 9t squared there, so it's now going to be minus 9t squared. We've got an 18t and a 36t, but that's going to be a minus 54t. And then we've got a minus 135 plus 135 equals 0, because we've changed the sign of everything. Now, here's the thing, as I was saying earlier, it might look promising, it might look a bit daunting, although we know how to factorise a cubic, factor theorem and all the rest of it. It may look a bit daunting, hit this, but in fact, we already know a lot about this, the solutions here, because we've got a repeated root here. Let's write it in red, repeated root. So, and that repeated root will be t minus 3 cubed, t minus 3 squared, not cubed, t minus 3 squared. So that's going to help us factorise, because if I could write t minus 3 squared, because that is going to be part of the factorisation of this and work it out. But in order to work out the factors easier, it might actually be better to write the expanded version of t minus 3 squared. That's t minus 6t plus 9. That's why it's quite nice. That's all about solutions to the thing, and all that stuff you did about repeated roots and all that is kind of relevant here. So we've got t squared minus 6t plus 9 because of the point B, which is a solution to this cubic. Okay, well now we know what the others, if that's correct, we know what these must be here. That must be 4t, so that the first term is 4t cubed, and that must be, this one here must be equal to plus 15, because we need to get plus 135. Okay, so I suppose that's cheating. It's not cheating, but it is now a good idea to check whether it actually does multiply, and we do get terms in t cubed, for example, in t minus 9t squared. Well, here we've got 15t squared, and here we've got minus 24t squared, and that makes the 9t squared. And the 54t, let's check that as well, I suppose. We've got 15 times minus 6 there. That gives us minus 90. But but we've also got a 9 plus 4t, which is plus 36t, which gives us our minus 54t. So yes, it is factorized, and we've got it. So now this is obviously, we don't need to state those factors again, because they're already the ones that correspond to the point B, which we already started with. So the other one we're interested in is for the point X, which is called in the question here. We've got t equals to minus 15 over 4. So we've got our parameter. So now it's just a case of finding the coordinates. So when t equals minus 15 over 4, x equals to minus 15 over 4 squared plus 2 times minus 15 over 4. Okay, and if we work that out, it comes to 105 over 16. Okay, exact as an exact answer. That does seem kind of promising, because that works out as 6.5625. And remember that it's 3 there and 15 at point B, so we expect it to be halfway between those. So that seems quite a reasonable answer. So we can say, so that looks good. So then we can say y equals minus 15 over 4 squared, cubed, should I say, cubed, minus 9 times minus 15 over 4. Okay, that looks a slightly more minus 1 to questionable, but I think it is right. Minus 125 over 64 is our coordinate for y. So we've done it. So let's write it out just finally. Just probably enough to guarantee the marks already, but let's just write it as a coordinate. 16 minus 1215 over 64. Okay, watch out for that repeated root thing. I've seen it before in certain questions, and it makes the question much easier if you spot the fact that t minus 3 is a root, at least one of them. But actually, if you spot that both of them are because of the repeated root, it makes the factorization nice and easy. Okay, that's it.